Hi, in this video, I would like to show you my newest electric energy meter or power consumption meter. It is a very nice color displayed device. Also can be remotely controlled via Bluetooth or another version via Wi-Fi. This is a Bluetooth version, and now let's see how accurate is it. So first of all, I apply the power. Let's see, the voltage is 233, and the meter also shows 233, and after a short time it will change its display to bigger numbers, and it can measure the voltage, the current, calculate the power, the energy consumption, and the frequency and the power factor, which is on a resistive load is 1, and on the inductive or capacitive load it is a different number. So here you can see 0 amp, 0 watt, and 232, the same voltage on both the device on the Fluke and this meter. Now I turn on a 40-watt bulb. Here is the bulb, and the current meter is also very accurate because it is 185 milliamps and 186 milliamps on the measuring device, so it is excellent. Later I will calculate the real power by multiplying the two numbers. Now turn it off. The next measurement will be a capacitive load. It is a very big 1600 volts capacitor, a very old one made in January 1968 in Germany, and it is 31.5 microfarads. Now that will be the load. Let's connect two wires onto it and put these wires to the meters. And now here you can see, the current is also accurate, but the power is very low, because the power factor is 0.01, so it is very low efficient. Such a big 2 amp current will produce about 500 watts. But now it is only 3 and a little more, because the current and the voltage are not in the same direction. So it is interesting measurement that this device can measure the fact that the current and the voltage are in different phases. Also, the frequency is sometimes not exactly 50 hertz. It depends on the electric power station. Now remove this. Now in the last part, let's measure a small mains transformer, a small value transformer as a coil. So now I change the measuring range on the Fluke, and it shows 11 milliamps, and the equipment shows 12 milliamps. The power factor is also lower than 1 because it is an inductive load. If I made a short circuit on the output, you can see 200 milliamps on both devices indicated, and also see the change in the power factor. Yes, it will be closer to the 1. And now it is, so I'm saying that is a good demonstration of how accurate this device. And now the next step will be the measure, the power consumption of this device itself. Now you can see how it is booting. The Wi-Fi is missing in it, but all the other is okay. And now it measures the voltage, no output current, and the power consumption is, according to this other measure device, only 1 watt. So it is not too much if you continuously want to measure something. You can turn this on and off. So if you press this button, this is power minus and power plus, power minus, turn off plus turn on. Also, you can control the output of the device, and you can do the same via Bluetooth here. I made some measurements about higher power, more than 800 watts. Or 1.6 kilowatts. Or 200 watts. Okay, that's enough. So the 2 meter measured nearly the same value. Now you can see both the on display and the Bluetooth display. Now I turn on the bulb, and the measurement is visible on the mobile screen. The problem is that the current scale is very big, so that's why this 175 milliamp is nearly nothing on there. But if I turn it off, it will be 0. Repeat the previous test with a higher power requirement device, a hairdryer. Now it is nearly 4 amps, and I can increase it. It is more than 7 amps. The amp is very low, but the yellow is the power. Now it is 1.6 thousand watts. Now it is half of it. And let's turn back to 0. Okay, and now I can reset everything. Yes. And now everything is 0 again. So that was the Bluetooth operation on a mobile phone. Thank you so much for watching this video. If you're interested in technical content and haven't already, please consider subscribing to my channel. That way, you won't miss out on my new videos, which will help you expand your knowledge in this area. Thank you for your support, and I look forward to seeing you in the next video. Goodbye.